This video will cover the second page of notes for the topic of log functions and their properties. Let's talk about transformed log functions. So very similar to what we've been doing for all of our functions, that we talked about the parent functions and what they look like. And now we're just going to see that we can shift them around left and right if we have a number inside the parentheses with x, how we can shift our graph up and down if we have a number on the outside, and that we have a multiplier in the very beginning that can tell us how we need to multiply those y values or multiply them by a negative to see the reflection. One big thing that I want to make sure we notice is that depending on the base, we know what our function is going to look like. If our base is greater than 1, it's going to be an exponential growth, which means that our log function will look like this. If we have our base is less than 1 but always greater than 0, meaning that it's a positive, we know an exponential will be an exponential decay. For our log function, it would actually look like this. This one would be a log of base b of x. So big thing that I really want you to notice is that if you have a base greater than 1, then your graph looks like this in terms of log. If your base is less than 1, then your log graph looks like this. So that will help us when we're trying to sit there and figure out the transformed log function. So for example number 1, our job is to graph f of x is equal to the log of 1/3 of x minus 2. So we just discussed that if we had a base less than 1 but greater than 0, then our graph should look something like this. So that's the reason why you see this part right here written down. So I went over it already, and now we can sit there and look at our points that we actually know. Remember, we know 1, 0 is always going to be true in terms of our log, and we're going to talk about that in just a second. And then we also know b, 1 will also be one of our points. So notice our base is 1/3, so I have 1/3, 1. And then the reciprocal of our base, so the reciprocal of 1/3 is 3, comma -1. So these are points that we're going to use when we're graphing. Now the other thing that we have in terms of our graph is we have this -2 in our function. So we're going to bring it down, and you see my horizontal line down here at y is equal to -2 because we brought it down 2. Notice we did not move anything left and right. All we have is an x inside of our parentheses. So our origin, our new origin, will still be with y-axis, but notice it will be located at this point in red. That's our new origin. So from our new origin, we're going to graph 1, 0. So notice I'm going to go over to the right 1 and then stay at 0. And I'm going to graph that in black. Then we're going to go 1/3 and then 1. So I'm going to go 1/3 and then up 1. And then I'm going to go over 3 and down -1. So 1, 2, 3 and down -1. Because we know what it looks like, we know that our y-axis is our asymptote. Going to get those 3 points and come out this way. So that's what our graph looks like. So big thing to remember is depending on the base, we know what it's going to look like. And then we still use our transformation. Stuff in the inside, move it left and right. Stuff on the outside still moves it up and down. And then we're going to use these points from our new origin. Let's graph g of x, where g of x is equal to the log of base 4 of x plus 2 plus 3. So a couple of things that we need to remember is that we have a positive base greater than 1. So our graph should look like this. And then we're going to move 2 to the left. So I'm going to put that in blue. So that's going to be our vertical line here. Our plus 3 is going to make it go up 3. So you can see my horizontal line here. I'm going to put it in red. This is my new origin. So from our new origin, we need to go to these 3 points. So let's do those 3 points. I'm going to put those points in black. So from our new origin, we're going to go 1, 0. So from here, I go 1 over and stay right there at 1, 0. I'm going to go B1, so that's going to be 4, 1. So from my red point, I'm going to go 1, 2, 3, 4, and up 1. And then we're going to go from our origin, we're going to go 1/4, because that's 1 over B, 1/4, and then -1. So down a quarter over and then down -1. And we can see that our graph needs to look like that. I'm going to connect my dots. And we can still see that it has an asymptote. In this case, we have a vertical asymptote at x is equal to -2. And we can still see that our graph is continuous and that it looks like this. And that concludes this video.